Okay.
You start? Okay.
Does it say it's going? It should be, yep. Lou, maybe you
Yeah.
and Shao, you want to introduce, and you could also mention that your students that are
Sure.
involved?
Happy to. Yeah, so, well, we're very happy today to have Iqbal Hossain here as our speaker. He's from the Office of Research, Innovation, and Impact at University of Arizona, his PhD in computer science and engineering from Bangladesh University. And he did a postdoc in Arizona, and he's got an expertise in networks, analysis, visualization, and he's really the key inventor of KMAP, which is a tool that the University of Arizona has been developing to analyze research contributions. And today, I think he's going to talk to us on the topic of global research networks. We have a number of other folks on the call here. Let me see if I can make sure I don't miss any of our students. I see definitely we're from the VIP class at Georgia Tech. I see Didier Contis, who's actually co-teaching the class with us. He's our interim chief information security officer at Georgia Tech. Who else is here? It looks like YYG is here. She's done some work in this area over the summer with us, and since we just had met class once, I want to make sure I'm not missing anybody. Is there anybody else on the call from the VIP class?
I see Kate Ting, who we haven't seen in a long time. Good to see you.
Great.
Good to see you, Dr. Harriman.
So, Iqbal, the floor is yours.
All right, thank you. So let me start sharing my screen. Okay. All right, everybody. So today I'm going to talk about World Research Topic Network. I think this is fun, but let's see how you feel. So in 2016, I started this project we call institutional knowledge graph and institutional knowledge map. So when I start this project, I thought, hey, what happened to the research topic? How research topics are connected to each other? And there are some place that you can get that hierarchical topic classification like that. So you have a bigger topic and you have multiple subtopics and you can narrow down more. But in practice, the way practically researchers work, that is not like this. This is like a non-hierarchical topic, right? So how do we get this, okay? How do we understand this? So that was the starting point. Then I dived into that and I found cool, interesting thing on that. So today I'm going to show how I collected that data. How did we process and generate network that we call topic network? And I have some interesting picture that you can see how different universities look like. Yeah, so that's what I call global picture. And then we have a research topic backbone. We have a system we can look. And we are using this topic network with our institutional knowledge graph. I can show that as well, how that looks like. Okay, so that is our goal. So let me start with data collection. As you already understand that I'm talking about Google Scholar data. So what we did, we collect world top 1,000 university and try to find their profile in Google Scholar, capture all of their data. So for example, this is a typical Google Scholar profile. You can see the name, the affiliation, the research topic, and the paper abstract and other information. Okay. So in 2016, we collected 500,000 of profile, Google Scholar profile. and we did analyze on that data. So first step was to try to understand the topic to topic network. So that means, so you clearly see that this list of topics here. So here's a couple of examples, this list of topics, and we have 500,000 of records. So that's very good, that's done. Well, there is a lot of problem. I mean, when you work on this kind of public data and coming from varieties type of user, so that is make a little bit challenge on processing data and making the graph all the way up to. So let me tell you a couple of examples here, special case. There's a lot of different type of scenario, but I try to bring few. So the list is not like this plain, okay? There's a varieties type of user input. We had to fight with this special type of input. Somebody tried to write vertical bars as a separator. Somebody tried to put double quote. Somebody is tried to put ranking 1, 2, 3, 4. That makes all difficulties. Somebody wrote email as well in the topic list. So, and this is a funny comment. Somebody in their research topic, somebody wrote that Google has automatically listed others. Okay.
Most of them are not my papers.
That's not an academic. An academic would have claimed all of those papers.
By the way, the highest ranked author or co-author is et al. That's actually a lot of et al.
First name Ed, E-D?
Yeah.
E.T.
E-T, oh.
E.T.
The extraterrestrial?
So,
I'm just messing with you guys.
so if you get any question, please type in chat. I will look once I go over. Okay. So once you handle this kind of data and some come up with a little bit clean, separated research topic, then you learn it another word. There's a graph algorithm, graph algorithms. Somebody says the graph analysis. Okay. So if you think about the bigger picture, they mean the same thing. We need to merge them. Otherwise, the picture is way different, because we started with 300,000 of topic, okay? Then slowly I narrow down with a couple of thousand, 6,000, the final topic. So then this part is pretty much understandable that there are some very specific ways to handle that. For example, we can apply natural language processing based method called stemming, lemmatization, that kind of technique. We can apply and merge them. So we did that. And then we landed to the next level problem that somebody write computer-human interaction, human-computer interaction. Okay, so basically the same thing. So there's another level of problem. And then if you go further, then somebody write a whole lot of variation plus short form, okay? So there are a couple of techniques that call text clustering. So if you apply different type of text clustering algorithm, then you will see that those are very close. If you set a threshold, then it's possible to merge all of them. Not this one. Now I couldn't find a good solution for this one. Okay, so, but all of the other case can be handled through some text text clustering method. Okay, so suppose I have a clean set of research topic and for every people. Okay, so 500,000 of entry, 500,000 of set. Okay. And then I try to understand the relationship. So that means that's very naive way to see how that research topics are connected. So that is, we can measure some co-occurrence. That means that if I work on algorithm and natural language processing, then you understand that the algorithm and natural language processing has some kind of relation. Now, if sufficient number of people say that we work on both algorithm and natural language processing, then we can assume that there is a strong relationship between these two research topics. So based on that, we can generate this topic network. So that topic network now is connection between topics, and the age relation tells us how strong that connection, and strong is a measurement of correlation. So I have a node and age weighted topic graph. And what is weight of the node? Weight of the node tells me how many people, according to our data, 500,000 out of 500,000 people, how many people are working on this particular topic. So that is the node, weight of the node, and is, as I said, this co-occurrence. So I got that network. Now it seems good. Let's proceed on. If you find an embedding of the network, then it looks like a typical graph embedding problem that you have a hairball. There's a lot of edges, there's a lot of nodes, and you cannot see anything. So that we call hairball. Now, how do we make more useful of this network? Okay, so that's another level of problem, that how we make it more useful. Okay, so if you render the topic network, then you can read the topic level, but still there's a lot of connection. We human cannot get that, understand that connection too much, because our brain cannot process that details. Okay, so that network is...
Iqbal, real quick question, sorry, but so the nodes here are the topics, and the edges, I thought you were looking at people who are working on the same topic, or like, what are the edges in this case? The strength of one topic to it. So if people list that they're working on some topics together and somebody else, I got it. Okay, thank you.
Yes.
I see.
Yeah.
It's not people. It's not a collection. It's not a connection of people. It's people who tend to work on similar topics. Okay.
Right. If sufficient number of people say that I work on these two topics, then I understand there is A. So that is the meaning of this is. Okay, so next thing is we try to build a application on top of this global research topic, and using that application, we actually able to see some of the picture that is coming from the network. Now, this is a bit technical, but I try to put, try to avoid all the mathematical things here, but try to put some keyword, and if someone wants to dig into them so that they can dig. So I have the graph embedding, how we can make an interactive application on that. Well, there is a lot of graph visualization software. We can put it and you can interactive, you can see. But our target was a little bit different, so that you can make more sense. I'll explain. I'll try to explain. So you have a graph, and then we find we find a good embedding. So that's the difficult question: a good embedding. What is a good embedding? We rely on SFDP. Force-directed algorithm, and then we did a geometric clustering, graph clustering, to see how closest, how the research topics close to each other. Okay, and then we did a boundary. After the boundary, we create we did a map coloring, so that we can separate each of the region is with a different color. And then so all of this thing is happening in offline. Okay. Then the next part is you have nice picture, static picture, or a SVG or scalar vector graphics. Now, now how do we make actually application? So from there, we extract graph elements, node, position of the node, position of the edges, color of the edges, and we compute the size of the node. Okay. Then we bring into the browser. In the browser, we rely on some map rendering tool. There are a couple of map rendering tools we use here. The skin you are looking here. So that is Google Map API, and that was a great mistake to use Google Map API. So all of the map we generate now using Mapbox is much more faster. So that's why we had to discontinue this application, but all of the data and Docker container available in our GitHub, anybody can use this. But this application is no more live. But we have a conference. We published this paper in Advanced Visual Interface Conference, and I have some screenshot that I can show to you. So in the application, what we are looking for, we are trying to find a way so that we can navigate the map, navigate the graph. And the graph is embedded as a map. Now we bring that functionality that you can see the most important topic. Then if you zoom in, zoom out, you can start seeing a little bit less important topic, okay? And importance, the notion of our importance is coming from how many people working on, very simple notion. Okay, then if you go more, then more smaller topic comes. And the reason of choosing the map, because when you have map, then you can see, if you know that this area, let's say this area is computer science, this area is biology, bioinformatics, this area is some humanities or some arts. So if you know that, then you can put information on top of the map. So that means you can get the information quickly. So that's why we're able to put some of the information on top of the map. So what is that information? So one thing we try to see what is our weakness and strength. So we have in our database thousands of university. Now, this is very, very simple measurement that how many people on average world has a specific area nowadays, and how many people I have in my university, okay? Using that measurement, we call SRI, that is the comparison between human resource investment. Of course, there is a lot of limitation. For example, in our Google Scholar database, we didn't differentiate whether this is a professor or a student, or this person is already left 2 years ago or not. That a lot of limitation, I would say. But still we found that makes sense. So let me show you. This is the University of Arizona, and this is the purple tells me that this is the area we have lacking. We don't have enough people. Okay, and the green area is we are good at that. Okay, by just measuring the how many people working on this area. Similarly, we had that measurement, and we can see that this is our strength, and this is our weakness. This is some measurement there was. And now if you look at other universities, then basically you will be able to compare how we are doing. Can we compare with Arizona State University or with Arizona University? So that is the comparison. If you look this picture, then this is just opposite of Arizona State University with Arizona University. At the end of the slide, I have a couple of other universities. If we want, we can look. Okay. So now the people count is Yeah, measurement, but not really very good measurement. There is another measurement. You can take the citation and sum up and do the similar picture. Then where is our strength? So that is the citation heat map. So we see that at the University of Arizona, we really have strength on this area, and this area, from this area, I can see this is a medical related topic. Okay. Yeah. And this is ASU. Okay, so it brings that since we have that baseline, then we can do a lot of things. For example, we can see how Arizona State University or Arizona University funded on different topics for a specific funding agency, right? So then we can see, we can take the grants.gov data and we can analyze the abstract. We can find what are the topic of the grants. We can get the number, the funding numbers, and we can see here, this is in the picture, we can see that we got good funding from NIH. So big bubble, and in the area tells me that is the health related area. But the same area, we see that NIH got funded, ASU got funded that mass. Okay, so that is a very, loose comparison. We can try to understand other thing as well. At the end of the presentation, I'll tell a couple of things that we can do. Okay, so since we had the data, we try to use as much as possible. So one of the things we try to understand what are the topics and their degree. So this is very easy measurement that how the other topics connected. We found that nowadays machine learning is connected almost half of the area of this world. Okay, this is very strong area now. And then artificial intelligence, neuroscience, modeling, all the way up to statistics. So this is the degree count. That means how strong this topic related to the others. Okay, so now we can try to see a popular university based on Google Scholar profile. Again, there's a lot of limitation. And so we can see that Stanford University has, so this data coming from Wikipedia, and this data coming from Google Scholar. Okay, so we can see that Stanford University academic stuff is that much, but they have profile that much. Okay, that kind of relationship. That relationship doesn't always hold. For example, University of Michigan has academic profile. That means it tells me that not all university use Google Scholar uniformly. Right, so that all of the whatever I said probably completely wrong or very partially true. Okay. Similarly, we try to understand what are the area and their citation. We found that particle physics or high energy really popular in terms of citation. We found that per person 15,000 of citation. Okay, and with the compare with this the area with information visualization, artificial intelligence, machine learning, we got 1,000 of on average citation per people. Okay, so topic network backbone. So you see the hairball now. Now, if we try to understand what is the main topic and connecting to one topic to another topic, okay, so we can do that. We can do by using maximum weighted spanning tree. So we compute a maximum weighted spanning tree, and that tells me that these are the main topics, and this is the, basically this is the highway of the topic. And we have some kind of different research that we can try to visualize the very highway, very top level highway, then progressively we can see the all details or not. So there is a two link here. We can, if we want, we can look, we can navigate. Yeah, but I always find interesting to look how the topic connected, and to me, it really makes sense that I hope I am in time. So
No, you're fine. You're fine.
so if I, when I, every time I come here and try to look how the connection, every connection makes sense to me. Epidemiology, public health, and all of these things, is really makes sense. Okay. Now, that is the all topic network, but our main goal was to use that topic network in our institutional knowledge graph. Okay, and so institutional, as you have seen in the last meeting, last seminar, that Laurie showed you how institutional knowledge we develop. So institutional knowledge map actually collects all piece of information and connect with the people, the research topic, department, the funding agency, grants, all of the thing as a part of institutional knowledge graph, we connect them, collect them, and visualize them. How that looks like. So I can show you our knowledge graph here. So still we are building. There's a couple of different type of nodes, and we see that 165 different type of 165,000 node, 38,000 of relationship. But in particular, if we try to look the topic network, then there is a two type of connection, topic to topic, and we can see how topic to topic connection. We saw a static picture, it's really messy, okay. Now this topic is actually connected with the people, and people and again connected with the bigger thing. Okay, yeah. So this is the topic to topic network. If I can explore from topic to people and people to other thing, since we are maintaining that relationship. Now let me show you a research interest. Okay. So this is this reddish node are people, and all of these yellow. Okay. Yeah, orange node are topic, and you can see more how topic and people connected. Connected means if I say Steve works on the couple of topics and he's connected, and we can look all the details of this person. Okay. So that is no more research topic, but I wanted to take 1 minute to show you the how other information connected, and we can actually use that power of the information to ask some difficult question for the organization that we can answer. Okay, so all of smaller node are publication. I saw some grants. And again, if you click on that, then you will see collaboration between the grants, and I can see the funding agency. So from topic to all the way, I came to the funding agency, and then I have school. Oh, probably this is department. Yeah, I can, if I click, then it will get messy because there's a lot of people working on these things. But you get an idea. Okay, I'll go back to the presentation. Okay, so that is the end of the presentation, but I have some other pictures, then I can show you if you are interested to see other university.
Yeah.
This is Stanford University, okay? So this is still human resource investment, okay? How is Stanford University look like? This is Harvard, MIT, Canada, Toronto University, Caltech. This is European or Japanese university.
Tsinghua. That's what it is. How about Georgia Tech?
So I didn't bring the picture. That's the old picture. Okay. So if I knew that you wanted this presentation, of
No
course.
worries. No worries. Very interesting. A lot of machine learning going on everywhere, it seems like.
Not only that, we try to group by to see the bigger picture, regional bigger picture. For example, this is the aggregated version of all European university. Okay. Yeah, this is all US university. This is all European university, all Asian university. Okay. So and then there is a different type of school. For example, this is all medical university. How it looks like all together. Without medical school, okay, the university without medical school, private university, how look like, public university, okay. This is, yeah, non-land grant university, land grant university. Is there anything else? This is all of the backup slide.
Iqbal, can you do a year? So can you see like how things evolve over time?
Okay, so that's the very good question. Let me here. Okay. So in 2000, it was started from there in 2016. Then we saw that there's a lot of potential, lot of things to understand. Then in 2020, the beginning of 2020, we collect more data. We refresh all the data, and those data is from 1 million of people, and Google didn't like it. Google put some extra caution so that we cannot take any more data. Okay, so now we have that version that is 1 million profile 2020, but we didn't analyze yet the difference, all of the thing. So if someone wants to interested working on that, then I can invite in our group to work on that. This is pretty cool thing, at least I think. I will stop and see if there is any question.
Yeah, that was great, Iqbal. Thank you very much. There is, I have a number of questions, but I'm going to bite my tongue because I know that we've been joined by, I see Zhu Chuk from Georgia Tech has joined us, and he had a question in the chat a little while ago. So why don't you start there?
Okay. Okay, that's very good question. How do I understand that this is a clean and up? We set couple of filter. For example, if there is a research topic, you are all only people working in this world, so we discontinue that. Okay, so that means there is a threshold if only in the whole world. So 1,000 university, I'm saying that is the whole world. Okay, so if at least 5 people doesn't work on that on a topic, then I discard that. Then another level of threshold I put when I make the relation between topic to topic. There is a threshold that if only 20 people say that there is a connection between some weird optical science and cancer biology something, okay, then I drop that. Okay, so I don't have any statistical method to measurement that this is clean enough, but since even the data is not clean enough, if you have enough evidence, okay, then you will see that some kind of makes sense or not. So that is the belief. There is no statistical measurement on that. Okay.
Thanks. Thanks for the explanation. Yeah, so I understand. Of course, there's no principled method to to decide, whether it's clean enough or not. But yeah, just from my research experience, that if you do this kind of stuff, there's this danger of losing out on long tail topics. You would capture lots of the the
Are you frozen?
He may have frozen for a minute.
Oh, you said we didn't hear anything after long tail topics.
Oh, sorry. Am I back on?
Yeah.
Okay. Yeah. Sorry. Yeah, I was just saying that building a clean set of topics or a clean set of entities, or like clean set of department, a clean set of persons, any of those entities, it's rather challenging. It's actually a research area of its own, which I'm worked a lot at, and there's a danger of losing out on long tail entities. Those entities are not studied enough. They are not mentioned enough, and this can create a bias, right? Because a lot of the people that are heavily present, and you mention them a lot in your entity, in your knowledge graph, but then there's a long tail of entities that are missed out by this data pre-processing, and those perhaps are the weaknesses of your organization that you want to focus on, right? If you lose out on those, right? So this is sort of a kind of a danger that
Agree. This is a hard problem, and this we can work on that.
Yeah.
Yeah, sure. Yeah.
Well, it's kind of like there's first order data here that and that's not always going to be sufficient. I have a couple. So yeah, in particular, you look at these topical analysis, and when you're dealing with people or organizations or papers that have doc IDs, there is a unique identifier. There's a PID, a persistent identifier. Topics are never going to have a persistent identifier because some topics are going to come and go. New topics are going to need to be added, and other, as we talked about in the email recently, how does a topic emerge in this space versus a topic that sort of is dying, and so that's longitudinal. I think that's interesting. But yeah, it's still it's really good work and great visualizations. And I'm wondering about, so this is just raw data from Google Scholar, and you mentioned maybe using Wikipedia instead of iPads for things, but I'm thinking we could probably get more reliable data sets because Google Scholar has itself a lot of biases, right? Whereas if we're working with Web of Science at Georgia Tech, which is a citation index, it still has gaps, but it indexes, almost all the major and many minor journals. It misses some books, it misses certain conference proceedings, it misses other things, but it's a pretty good starting point, because even if those things are not indexed, if they were cited, like you publish a paper that cited a conference proceeding, that conference proceeding will appear in there, and the keywords are tied to the paper, not to the authors. So you actually could say if a paper has 5 co-authors, then all 5 of those keywords that are actually written on the paper itself are in fact tied to those co-authors. And so it's a little more reliable than the self-reported Google Scholar fill in your research areas field. But it could probably be amenable to a similar analysis.
I don't know if, US patent data would be interesting too. It doesn't have topics per se, but you could still get who is working on particular things. That might be interesting too, to integrate, if you could integrate this. Yes.
So the reason is to go for Google Scholar, because every person reported their own research topic. I see that is the value. I mean, all of the other system, I look Microsoft database, Microsoft academic database, I look Dimension database, I saw the Web of Science. So I didn't like too much but that is the 3-4 years old. Okay. So
Yeah.
I didn't like too much because the topics looks like not like how we talk, right? So
Yeah.
so that topic is either very narrow or very like so you take a word from abstract, that not always a research topic, but
Oh, yeah,
all
yeah.
of the method is look like they use something and you use some fancy word, some processing or something like that, and then that come up as a research topic, but that is not. So I try to capture how human actually say that is a topic, okay?
Right.
So that actually gives a Google Scholar that when human write their Google Scholar, all of the other system, the original researchers, they don't have opportunity to write their own research area, right?
Yeah. Well, I think Web of Science pulls the keywords directly off the paper, which I think are typically provided by the author. But yeah,
Okay.
and yeah, certainly it's a. I mean, entity. I don't have. We have an expert on the call here, so you know, I don't know. You're basically, Zhu, do you want to say anything about your work on this briefly?
Yeah. So thanks, Lou. For those of you who don't know me, I'm a faculty here in Georgia Tech in computer science. So I do a lot of research in entity matching, data cleaning, data integration in general. So, you know, what you're describing, good work, by the way, is sort of a application data integration where you want to pull data from different data sources, in your case, Google Scholar, to build some kind of visualization application to serve various purposes, right? And you know, Lou mentioned that, you know, Web of Science and other data sources, you know, in my experience, each different data sources would have a different, you know, characteristic, right, or strengths, right? And for example, even Web of Science that I can think of, right, does not cover computer science publications that well, perhaps journals and stuff, right? And for computer science, we go to DBLP. And that is sort of a community driven, and it's extremely comprehensive. So it's a kind of a de facto standard of how we look at publications and related work in computer science, right? So there are many, many different data sources, Microsoft Academic Database, Google Scholar, as you guys did. And I think sort of, you know, the best way to do is to pull data from all different data sources if we want to be really comprehensive in building such a knowledge graph, is to sort of, you know, pull data from all data sources and integrate them. Now, that's not the easiest thing to do because, you know, data sources overlap, they conflict, and they provide different information. They have different trustworthiness. But, you know, that's whole slew of, you know, interesting research problem that, you know, I look at in my own research. But, you know, in general, to build such a, you know, comprehensive and as clean as possible knowledge graph, we need to sort of utilize data from multiple different data sources. That's sort of, you know, is sort of the bottom line. In my opinion.
Yeah, that's good. And Microsoft's academic graph, by the way, is going away at the end of this year. I think they've announced, right? So it was an interesting project, but they obviously aren't pursuing it, or maybe someone else will take it over. I'm not sure. Yeah, I'll put a link to the chat in that in case you guys were not watching that. I just found out about that this summer.
Hey, Lou,
yeah.
I don't know, I don't want to take it too far off, but Iqbal, I just wanted to ask you a little bit about the tools you're using. So I saw that you've got Neo4j, you're using some of their visualization tools, and actually I'd like to hear a little bit about, I used that a long time ago, so I wouldn't mind hearing a little bit more about kind of how that's evolved. But the visualization libraries you're using, and any other kind of web infrastructure, can you just really quickly, you know, mention kind of the tool set that you're using here?
Sure. So, so there's a couple of tools we are using here. If we think about only the application level, not the data processing pipeline is different. Python thing and all of the other thing, NLP thing. So for the application level, we are using Node.js server. So that's our main, the main web server. And then we are rendering map using Mapbox. So as I said that earlier, we used Google Map, and that is super slow. and we use Mapbox.
I don't know about that.
Yes, so that the visualization. So what we did, we actually pre-compute everything so that when user interact with our system, so that we can serve very fast. So that's why almost all of the interaction is pre-computed, okay? Because you see there's a lot of information and it will get slow. So in the offline, we use GraphViz software, okay, to render all of these things, make the image, and then we parse image to find the coordinate and make it 0, 0, 1.
Box. But no, after that, sorry, what was that, the last one you said you were using?
GraphViz. Okay.
Oh, great. Oh, gotcha.
Yeah,
Gotcha. Yeah, I know it. Yep, I know. Cool. All right. Well, you've done it's really nice.
Why I can show you a slide, and I try to put all of the things. Probably that would be much easier. Hold on. Okay. So this is the
there we go.
all technology we are using.
Oh,
so Mapbox is here. Is there any question?
No, this is a really nice slide. Yeah, okay, cool. This answers it very quickly.
Okay, so we use React, we use Mapbox, we use D3s, Node Express Server, we have MongoDB, we use Java, we also use Lucene, some of the old version. Okay, in the data processing, we use Python, some machine learning model, NLP, MongoDB, as you know, web crawler, some API. Map generation part, we use GeoJSON. GeoJSON is a special JSON file for rendering map. We use SVG, this is the word you are looking for, GraphViz. In GraphViz, there's a couple of different packages embedded, SFDP, Nito, Gmap. We use Dart programming language. We use some testing environment, Puppeteer, and Zeiss for the unit test, and also for web application test. Is that
Very
good
good,
enough?
thank you. Yeah, thank you, perfect. That's a really nice overview. Did you all have any other questions? What's next then? Yeah.
Next, as I said, that we have millions of profile data. Of course, we can do better. We can try to see what difference has been made in last 4 or 5 years. We can find a lot of interesting picture globally or even in university. Though data is biased, there's a lot of challenges to merge 2 data set. There is no unique identifier, right? So yeah, there's a lot of things we can do. You guys experience on that. You tell me what we should.
Interesting.
Yeah, this is great, Iqbal. Thank you so much. Did anybody else have any questions, comments, insight? All right.
Iqbal, I have one last question. Sorry, just what did Google do exactly to thwart your ability to act? What did they change?
Well, that's a good question. So you know that Google, if you do multiple requests in Google, they block it. But we did little bit intelligent on that. So that's why we able to download data twice in 2016 and 2020. So what we did, we tried to manipulate session variable. If you open your browser and take a session variable and then put that variable in Python code so that it looks like real, and we try to mimic some human kind of request. For example, we don't do continuous request to Google server.
Sure.
We did some kind of a random.
That's cool, huh?
Okay.
That's a hacking technique. Yeah, this is. So slowly, yeah, exactly, yeah, so they're trying to, that's really interesting. So how did they detect you then?
Then when we published the paper and then they realized that the people are working on this data, they put some extra, probably some extra rules or something like that. They can now, if I do the same rule, okay, if I run the same code, they actually guess that I'm doing by machine, okay? So nowadays, it's really difficult to get the data, but yeah, who knows, there is another way of it.
Okay, we should find a way around that.
Yeah, we ran into that same problem. Google Scholar does not have an API. So the only way you get it is faking web browsing. I mean, your Google Scholar is meant for sort of small interactions, not for large scale data. I think they, at some point, thought about managing their, selling that data or something else, but you can't just grab it all without doing clever things like Iqbal has. Or else they'll also, they'll also block your IP. And I mean, they just make it very hard.
But the dimension, if you have subscription to dimension, is that the system do you know this system?
Yeah, Dimensions is one of the data science products like Altmetrics and Figshare, and they also make
Dimension they have API, they allow to download. So if you want some easy thing, then that is the one way.
Dimensions also costs a fair amount of money. It's like academic analytics.
Yeah. Okay, what if you crowdsource this? So what if you were to create, like, what's that one that looks for extraterrestrials? And they crowdsource it.
SETI at home.
SETI at home, yeah, man. You could do a SETI at home, have individuals join in, and then you could have them send it to you. Maybe you could crowdsource this.
So you want to set up the internet versus Google? That'll be a fun one to fight.
Yeah, exactly.
So, yeah, I mean, actually, there are basically projects today that are trying to do using blockchain distributed federated knowledge graph. And so to your point, it would be possible for every institutions to try to based on the personal vita from their faculty to try to populate their own local knowledge graph. And then you just need to have an incentive for each institutions to contribute on this distributed knowledge graph. So you do federated learning.
I like it. That is something that would be good if we could organize in that way.
So there are some projects that have been trying to investigate. There is actually some attempts to create this kind of Neo4j and all of this, OrientDB, etc. All of these projects are really centralized knowledge graph, and there are basically a lot of attempts, like Lou and I have seen, about trying to create this centralized knowledge graph. That doesn't work. Even I think the NSF with the open knowledge graph initiatives is running into this issue. And so really, I think that's maybe an area of partnership, which is how do we start to have these incentivizations to do that. I'll paste into the chat some projects that are blockchain oriented that try to incentivize people to do this federated knowledge graph.
All right, that's pretty cool. Huh.
Well, looks like we're coming up on time. Thank you all for taking an hour out of your Friday, and I hope you all have a good weekend. Iqbal, thanks so much. That was a great presentation, and I hope you can share your slides. Greg or Hossain or someone can put them up, the slides and the recording on the website once you have them. Because I know Cassidy Sugimoto was interested, but she's not going to be able to hear. And so there will be people who want to watch this recording, but I don't think it's going to go for an Emmy this year. I think we're going to probably.
Okay, with that.